In a microservices setup, how have you managed database transactions, especially when multiple services need to coordinate changes atomically?
That's a very important question, especially in distributed architectures. In monolithic systems, transaction management is fairly straightforward, using ACID properties and database-level transactions. But in microservices, each service often owns its database, and we must coordinate changes across boundaries without relying on traditional transactions. In one of our projects, an order placement flow involving inventory, payment, and shipping services, we used a Saga-based transaction management pattern. Each service performed its part of the transaction and then published an event to move the workflow forward. If any step failed, compensating actions were triggered to roll back previous operations. 4. If inventory was successfully reserved and payment was processed but shipping failed, we would publish a rollback event that released the inventory and refunded the payment. This approach ensured consistency while preserving autonomy across services. We chose an event-driven architecture, using Kafka for reliable communication between services. Each service had its own state machine to track the saga and emit appropriate events. Timing and idempotency were critical, so we implemented deduplication checks and retry logic. We also used Outbox pattern to ensure that domain events were persisted atomically with database changes. This avoided issues with lost events due to service crashes or network failures. Monitoring these distributed transactions required traceability. We correlated events using unique transaction IDs and visualized workflow status with dashboards that aggregated Saga progress. In short, database transaction management in microservices isn't about enforcing strict atomicity. It's about orchestrating consistency through careful choreography, compensations, and observability.